Oh, okay. Other people don't need to know.
So let's look at 1c. Y equals 3 minus x, or negative x plus 3 if it helps. So we start at a plus 3. Our slope is negative 1. So when we get to x equals 3, and then x equals 0, y equals 0. So this little triangle down here. Remember, base, axis, reflect, circles. Thank you. So pick some key points to reflect over. So I saw some people using IDs or other straight edges to really make their pictures sharp. All right, so disc or washers here? Definitely washers. Let's see. So can you visualize what's going on here? So,
it's like the one where we poked it and then the pencil all the way through.
Yeah, but we poked it with a pencil and poked it all the way through, right? Like took a cylinder, poked a pencil all the way through, and pulled our pencil back out. I've kind of switched my order on these. I like to make sure I got the dx dy thing correct, because then that sort of sets everything up. So are these washers stacked in the x direction or the y direction? X. So I know this is dx. So I need to add up all the washers from 0 to 3. Put my pi on there before I forget it. And then it's just r squared minus r squared. But the trick is figuring out big R and little r. Always draw your r's from the axis. So there's big R. What's big R equal to? 6. So it's a constant 6. Little r is changing. There's little r. Ooh, but little r is not measured from the x or y axis, so I'm going to have to do some rearranging things to get what little r is. Because from the axis, that's the y value right there. So what's little r equal to? 6 minus y. That's a good place to start. It's not the final answer, but it's a good place to start. Little r is the full 6 minus the y. 6 minus negative x plus 3. Obviously, you could clean that up a little bit, or you could just leave it like that and not worry about it. And you can leave your answer in that form. See if I can find the screenshot that I took. From my favorite Facebook group. This was just yesterday. I'm wondering if this is good for notation. We get lots of questions like this because some of the AP graders are in this group, and so they'll say, yeah, that's good, or no, you need to explain further. And so this teacher, I'm sure they're grading somebody's test or homework, and they said, I'm wondering if this is good for notation. Are there better ways to write this integral, or is this the most common way? And you can see a little bit of what's going on, but basically they're curious is this enough work shown? And one of the graders responded, yep, that looks perfect, because The reason is they've defined what big R is and defined what little r is, so you don't have to do all the substitutions. Like, once you've defined everybody, like, you're good. So that means I will be okay with what we did over here. And then they typed it in the calculator and got 5 pi over 6. So r squared minus r squared is okay to leave it, as long as you've told me what big R and little r are. Yes, sir?
We also do 2B.
Yes, 2b,
I mean 1B.
1b, and then we'll do 2c. 1b. Again, same base. The line y equals 3. I'm just thinking they didn't have the best possible window for this one, did they? But that's okay, we can still work the problem. Alright, so this is the cylinder that they poked the pencil in and got just to where the point was at the very end and then pulled the pencil back out. So it's a cylinder minus a cone. Which means I can, in some ways, answer this final question already. Pi dx 0 to 3 r squared minus r squared. So it's like, I already have the final answer ready to go, but I need to figure out what big R and little r are. Big R from the axis to the outer edge. From the axis to the outer edge. That looks like it's a constant 3. Little r. Again, if you're not measuring from the x or y axis, it's going to be a little bit weird. I'm going to say that's 3 minus y. So 3 minus negative x plus 3. (2c). Okay. X cubed, x equals 0, y equals 8. Y equals 8. X equals 0. And x cubed. So 1 cubed is 1. 2 cubed is 8. So there's my base area, and that'd be the same base area for all of them. So it's sort of attached to the y-axis more than attached to the x-axis. The line y equals 9. So then we've got to reflect across that. Uh-oh, this one goes outside the... goes off the page a little bit. So sort of a bullet, but with a pencil poked all the way through it. A missing cylinder on the inside of it. Let's see, those are stacked up along the x-axis, so dx. The washers go from 0 to 2. And by the way, that would get you partial credit on the test. Like that's a lot of work already there. That you know that it's a washer, you've got 0 to 2, you know it's dx, you know it's r squared minus r squared. I mean, it's probably not half credit yet, but it's something. So hopefully everyone can get that far. And then now the trick is, well, what's big R and little r equal to? Big R to the outside edge. Again, if you're not measuring from the x-axis, things are going to be a little bit weird, like you're going to have to do a subtraction. So that looks like 9 minus y, or 9 minus x cubed. And you know, if you want to check some, you can plug in points and see if it matches. So when x is 0, big R should be 9, and that fits the picture. When x is 2, big R should be 1, and that fits as well. How about little r? That's just 1. That's a constant 1. And then since we've already done the setup, we're good. Like that's all we have to do. I should say that's all we have to do for this worksheet. On the test, I want you to type it into the calculator and give me a number answer. Any other ones you tried and were curious about? We didn't do any dy problems. Which one? 1e. Let's see, x equals 3. So that'll be a dy problem. 1e. So same base as the other ones in number 1. Axis x equals 3. So yeah, right away I realize this is a different rotation this way. So my discs, or I guess my washers, will be stacked up in the y direction. See, base, axis, reflect, and then circles. So this is sort of a bowl, I guess. The outside's a cylinder, but it's hollowed out with a cone. My washers are stacked in the y direction, so I know it's dy. They're washers, so r squared minus r squared. And they're stacked from 0 to 3. All right, how about big R? What's big R equal to? That's a constant 3. Big R is not changing. The outside of this thing is a cylinder. Little r isn't measured from an axis, so it's going to be a minus problem here. I would say 3 minus x to start with. That's not good enough because I need it in terms of y, but it's not wrong. What does x equal? Let's see, y equals 3 minus x. So if I move things around, x equals 3 minus y. So 3 minus y, which you can leave that as is, but that one simplifies to just y. And again, we already had the washer part set up. Pi r squared minus r squared. Anything else? Happy spring break then.